Hi class, here's the Chapter 6 review guide. Okay, the sum of the exterior angles of a convex polygon, one angle at each vertex, is going to be equal to 360. It's the sum of all the angles on the outside, one angle at each vertex. The sum of the interior angles is found by using the formula S sub I equals n, where n is the number of sides minus 2 times 180. So if we want to find the sum of the interior angles of a 10-sided polygon, we would use this formula for the interior angles. S sub I equals n minus 2 times 180. And we'll take 10 and put it in for the n. And that gives us 8 times 180, which is equal to 1,440 degrees. Now, if we want to find the sum of the exterior angles, you remember that the exterior angles is going to be equal to 360. The interior angle sum of a polygon is 2,160 degrees. So we're talking about the interior angle sum. So we'll use this formula. S sub I equals n minus 2 times 180. In this case, we don't know the number of sides, but we do know what the sum is. The sum is 2,160, and that equals n minus 2 times 180. So we're going to solve for the number of sides. In order to get n minus 2 by itself, let's divide both sides by 180. $21.60 divided by 180. On the left-hand side is going to be 12. So we get 12 equals, on this side, that cancels, n minus 2 all by itself now. And then to get n completely by itself, we add 2. N equals 14 sides. If you have a 14-sided polygon, the interior angle sum will be 2,160 degrees. Given a regular 15-gon, what is each interior angle? Okay, we're talking about interior angles, so we'll use S sub I equals 15 minus 2. It's the number of sides times 180. That's 13 times 180. Equals 2,340. If we want to know the number of sides, if we want to know what each interior angle is, since it's a regular polygon, we're going to divide by the number of sides, which is the same thing as the number of angles, and that will tell us how much each interior angle is. So I'm going to divide this by 15. Interior angle sum divided by the 15 is 156 degrees. So each interior angle, each eye, is 156 degrees. What are the names of the polygons? A 3-sided polygon is a triangle. A 4-sided polygon is a quadrilateral. Quad meaning 4. Studied lots about quadrilaterals. 5-sided figure is a pentagon. 6 is a hexagon. 7 is a heptagon, or you could call it a septagon. An 8-sided figure is an octagon. 9 is a nonagon. And 10 is a decagon. Okay, here we have a polygon. It's got 6 sides, 1, 2, 3, 4, 5, 6. So this is a hexagon, 6-sided figure. And we need to solve for x. These are interior angles. So we need to know, what do all these interior angles add up to? Well, we use S sub I equals, it's 6 sides, so 6 minus 2 times 180. That's 4 times 180. That's 720 degrees. So the interior angle sum is 720. That means that all these angles need to add up to 720. We can write an equation and solve for x. 120 plus 130 plus x, that's 2 x's, plus 120 plus 110, all has to equal 720. And let's simplify this some more. I already combined the 2 x's. 120 plus 130 is 250. 250 plus 120 is 370. Plus this is 480. So 480 plus the 2x on the left-hand side is going to be equal to 720 on the right. Subtract 480. We get 2x equals 200. Divide by 2, and we get x equals 120 degrees. In number 8, we're asked to find x and the exterior angles. These are exterior angles, one at each vertex, so they each add up to 360. They all add up to 360. So 100 plus x plus 10 plus 2x plus 2x equals 360. Okay, so let's add up this left side. 110 on the left side plus 1x plus 2x is 3x, 5x altogether. We have 1 plus 2 plus 4, 5, that's 5. And that equals 360 degrees because the exterior angles add up to 360. Okay, and we solve for x. Subtract 110. 5x equals 250. And we divide by 5 and we get x equals 50. We'll continue to find the measures of interior and exterior angles. In this case, we're asked to find each interior and exterior angle. So we'll find the sum and divide by the number of sides. Well, an equilateral triangle, the interior angle sum is equal to 180. So S sub I equals 180. If we want to find how much the interior angle is, each one, divide 180 by 3. And that equals 60. And to find the exterior angle, we can just take 180 minus 60, and we get 120. I'm going to draw a little picture to show you why. Here's a triangle, and there's an exterior angle. Now, inside these all have to equal 180, so if this is an equilateral triangle, they're all 60 degrees. Well, then this exterior angle here has to be 120, because this is a linear pair, and they're supplementary. So if you find the interior angle, then you can just subtract it from 180 and you'll get the exterior angle. Okay, so a square, 4 sides, that's S sub I equals n minus 2 times 180 equals 2 times 180 equals 360. Remember, this is the only shape where the interior angles sum to the same as the exterior angles. Okay, then if we want to know what each angle is on the inside, we take 360 and divide it by 4, and we get 90. This is a 90-degree angle. That means that the exterior angle is also going to be 90 degrees, because 180 minus 90 is 90. The interior angle is 90, so the regular pentagon, the interior angles are equal to n minus 2 times 180. It's 5 minus 2 times 180. That's 3 times 180. That's 540. So the interior angle sum is 540. Now if we want to know what each interior angle is, we'll take 540 and divide it by 5. And that would be 108 degrees. So each interior angle of a regular pentagon is 108. That means the exterior angle is equal to 180 minus 108, which is 72 degrees. Now here I'm going to do this one a little differently. This time we're going to find the exterior angle, because you can sometimes find that more easily. The exterior angles sum to 360. So if we take 360 degrees and divide it by 6, because that's what a hexagon is, we get 60. So our exterior angle is 60 degrees. Well, then our interior angle is going to be 120 minus 60. So that is, 180 minus 60, which is 120. Regular octagon. If we want to know the exterior angle, instead we can find the exterior angle first. Take 360, divide it by 8, and we get 45. So the exterior angles of an octagon are 45 degrees, and the interior angle is going to be equal to 180 minus 45, which is 135 degrees. Okay. Now, parallelograms have 5 very important characteristics or properties. Opposite sides of a parallelogram. Right, I'm just going to sketch one. There's our parallelogram. Opposite sides are parallel. That's part of the definition. That is the definition. Opposite sides are congruent. Opposite angles are congruent. Both pairs. Consecutive angles, the ones that are right next to each other, are supplementary. And diagonals, I'll draw it again, diagonals in a parallelogram, they bisect each other. In a rectangle, diagonals are congruent. Not only do they bisect each other, they are also congruent. In a rhombus, diagonals, here's a rhombus, all sides are congruent. Diagonals bisect the opposite angles. So this diagonal bisects this angle and this one. They bisect each other, and they are perpendicular. So they meet in the middle at a 90-degree angle. So this angle in here, I'll draw it again. This angle where they meet is a 90-degree angle, and that means they are all 90 degrees. 90. The 5 ways to prove that a quadrilateral is a parallelogram, on page 415. You can show that both pairs of opposite sides are parallel. That's the definition. You can show that both pairs of opposite sides are congruent. You can show that both pairs of opposite angles are congruent. If those things are true, this is a parallelogram. If the diagonals bisect each other, you have a parallelogram. And last, if you have one pair of opposite sides that is both parallel and congruent. So just one pair. It looks like this. Here's our parallelogram. Let's pick this top and the bottom. If this top and bottom are congruent and they're parallel, then that's enough to prove that you have a parallelogram. Whoops. You have one pair of opposite sides. So I picked the top and the bottom. This side is congruent to this side, and this side is parallel to this side. then that's enough to show that this is a parallelogram. Okay, page 2. Let's find some measures in these parallelograms in different shapes, different quadrilaterals. Now A is kind of not a very good problem. I'm going to fix it for next class. But this is a rhombus. It doesn't look like one, but this is a rhombus. And remember, a rhombus is a parallelogram. It's a type of parallelogram, and opposite angles are congruent. So this angle and this angle are congruent. And also in a rhombus, the diagonals bisect the angles. So that means that this angle here is congruent to this angle. This piece is congruent to this, and this piece is congruent to this. Well, since these two angles are congruent, then their halves are congruent to each other and to the ones across the way. So that's why we can say that 4x plus 1 here is equal to 3x. I think that's a plus. All right, so if we're going to solve this, we would move 4x over. And we get 1 equals negative x. To make x positive, we multiply by a negative. And we get x equals negative 1. This is a very bad problem, because if x equals negative 1, then this angle equals negative 3. And that's just not what's happened. That's just not the case here. We can't have a negative angle here. But the idea is just to recognize that this half of this angle is going to be congruent to this half of this angle, since these angles are congruent. So the other equation we can write is 7x minus 2, I think that says, equals 9y. Oh wait, it's a y. 7y minus 2 equals 9y. So I'll subtract 7y from this side, subtract 7y from this side. We have negative 2 equals 2y. Divide by 2, and we get y equals negative 1. Okay. Now, letter B is a parallelogram. That means that opposite sides are congruent and opposite angles are congruent. Right, so I said that wrong. Opposite sides are congruent and opposite angles are congruent. All right, so we can solve for x here because these two angles are congruent. 3x equals 2x plus 33. So we subtract 2x from both sides, and we get 33 equals x. Now if we want to find y, we can recognize that in a parallelogram, opposite angles are congruent and consecutive angles are supplementary. So whatever this angle is, we will subtract it from 180 to get that angle. Or whatever this angle is, we can subtract it from 180 to get that angle. I'm going to use this one. So I'm going to take 33 and put it in here for the x. 3 times 33 equals 99. So this angle is 99. That means that this angle, y, is equal to 180 minus 99, which is equal to 81 degrees. So y equals 81 and x equals 33. Letter C, we have a rhombus. And the most important fact here to start solving for this variable here is to know that the diagonals are going to meet at a 90-degree angle. They're perpendicular. Okay? We know all the sides are congruent. We can't find y or 2x. We can't find these two angles until we know what x is. Well, 3x is equal to 90. If we divide by 3, we get x equals 30. Okay, so we know that this angle is 90 and this angle is 90. So we can find this angle right here. This angle right here is 2 times 30, so that's 60. So we know that this angle is 90 because once one angle is 90, then all of these angles are going to be 90. So this is 90, this is 90. So x was 30. We found the measure of this angle to be 60. 90 plus 60 is 150. To find y, we just take 180 and subtract 150. Why can we do that? Well, this is 90, this is 60. This has to, all three of these have to add up to 180. This is a triangle. So y equals 30. And 30 plus 60 is 90, and 90 plus 90 is 180, so that checks. So x equals 30, and y equals 30. The square, we're asked to find x and y. Well, I can find x because I know that a square is a type of rhombus, so that means that these diagonals bisect the angles. So this angle is congruent to this angle, and this angle is congruent to this angle. And not only that, in a square, all the angles are 90-degree angles. So 9x is equal to 90 divided by 2. This is half of 90 right here. 45. So x equals 5. Remember, in a square, all the angles are 95 degrees, and half of them is 45. Right? They're being bisected. There's a lot of symmetry in a square. Okay, now if we want to find y, that's the length of the side. We're given a part of the diagonal, but we haven't been able to find a measurement for the sides yet. Well, diagonals bisect each other. If this measurement is 8, then so is this one. Not only that, in a square, remember there's a lot of symmetry, the diagonals are congruent, so all the halves of the diagonals are congruent. So these all equal 8. So if we want to find y, we can use the fact that this is a square, and we have a right angle here, because the square, like the rhombus, has diagonals that meet at 90 degrees, and we have a right triangle. So we're going to use this right triangle right here. I have my highlighter, but I'll go ahead and just pencil this in. This right triangle right here. And we'll use the Pythagorean theorem. Leg 8 squared plus leg 8 squared equals y squared, the hypotenuse. 64 plus 64 equals y squared. It's 128 equals y squared. Take the square root of both sides, and we get y equals the square root of 128. That was an involved problem. We had to remember that the diagonals bisect at 90 degrees, they're perpendicular, that this piece and this piece and this piece and this piece are all congruent, so we had to label those as both 8. Then we had to use the fact that these were legs of a right triangle to solve for the y. So that was an involved problem. Okay, number 13. If the trapezoid bases are 12 and 15, what is the length of the midsegment? Okay, I'm going to go ahead and sketch it. Here is a trapezoid, which means that it has exactly one pair of parallel sides, and we have here a midsegment. How do I know? Because it's bisecting that side, that leg, and bisecting that leg. So if the bases are 12 and 15, so this one is 12 and this one is 15, what is going to be the length of that midsegment? It's the average. You take base 1 and add it to base 2 and divide by 2. And that will give us the length of the midsegment. So that's 27 divided by 2. We could simplify that if we wanted to 13.5, but that is the length of that midsegment. Okay. Now, what if we have a trapezoid? Again, and we have a midsegment, which is going to meet from the midpoint of this leg to the midpoint of this leg. And this time that we're told one base is 15 and the midsegment is 12, so we're given the midsegment this time. What is the other base? Well, we have to set up our equation. Let's call it x. What is this other base? We add the base together, 15 plus x, and divide by 2, and that needs to equal 12, the length of the midsegment. Okay, base plus base divided by 2 equals the midsegment. So now we have to solve for x. Multiply both sides by 2. Do this carefully. So when we multiply both sides by 2, that cancels out the fraction, and we get 15 plus x on the left-hand side. We keep this. On the right-hand side, we multiply by 2, so we get 24. And then to get x by itself, we subtract 15. So x equals 24 minus 15 is 9. So this base is 9. And the picture doesn't look exactly like it should, but it gets the point across. Okay, in the isosceles trapezoid here, can we find the measure of angle S? Now your copy will be a lot better than mine. So this is 63 degrees. This is an isosceles trapezoid. Notice the legs are congruent. They're both 14. If this is 63, then it says find the measure of angle S. Well, let's find the measure of angle R first. Remember that this is the base and this is the base, so base angles in an isosceles triangle are congruent. So that's 63 degrees and that's 63 degrees. Now, to find these two angles, or find a measure of angle T, it's just remembering that consecutive interior angles are going to be supplementary. So this angle is 63, this angle is going to be 180 minus 63. And opposite angles in an isosceles triangle are also going to be supplementary. But once we find this one, these two base angles are congruent. So 63 from 180 is 117. So the measure of angle S is going to be also 117. And the measure of angle T was 117. Base angles, base angles. Okay, given isosceles trapezoid, if PZ equals 2x, and TR equals, and ZR equals 3x, and AT, this whole thing, equals 4x plus 8, let's find x. This is an isosceles trapezoid. So not only are the base angles congruent, so this angle and this angle are congruent, and this angle and this are congruent. Not only that are those congruent, but the diagonals are congruent. So I can set 2x plus 3x, these two pieces together, and that's going to equal this whole piece here, 4x plus 8. Add those together to get this diagonal, and that's going to be equal to that diagonal. So that's 5x equals 4x plus 8. Subtract 4x from both sides, and we get x equals 8. That was for A. Now for B, in the same trapezoid, we're told that TPR, remember TP, this middle letter is where the angle vertex is. So we're going to put our 3y right in there. And APR is y. And PTR is 60. So this whole angle, PTR, is 60. So this angle is 60, and this angle here is 3y and y. So can you see here we have this whole angle here is going to be 3y plus y. That whole angle is going to be 4y. This piece plus this piece. So 4y. And then this angle here is 60. Now these are consecutive interior angles here, because these pieces here are parallel. So these are going to add up to 180. They're consecutive angles along the leg. So 3y plus y is 4y, and that plus 60 equals 120. Excuse me, 180. All right, let's solve. Subtract 60, and we get 4y equals 120, and then divide by 4, and y equals 3. This piece of the angle, this whole angle is 3y, this piece was y. Added together, they become 4y. This whole angle here is 60, so 4y plus 60, these two consecutive angles along the leg here have to add up to 180. Number 17. Here's a kite, find x and y. Here we're going to find x. In order to solve for x, we need to remember that the diagonals are going to be perpendicular. So that means we have a 90-degree angle. So that means we have a right triangle right here. I'll go ahead and darken it a little bit. We have this angle this side, this side, this side. And we can use the Pythagorean theorem to find x because we have a right triangle. 5 squared is one of the legs, plus 11 is the other leg, equals x squared. That's 25 plus 121 equals x squared. That's 146 equals x squared. Take the square root of both sides and we get x equals the square root of 146. In this kite, we're given the angles and we're asked to find x and y. And in a kite, there is exactly one pair of opposite congruent angles, and it's the pair that is created by the two non-congruent sides. So this side and this side are non-congruent. So it's this angle and this angle that are going to be congruent, not these two. These two are formed by the congruent sides. So if that's 100, then x is 100. Now this is a quadrilateral, so all the angles have to add up to 360 degrees. So if we take 100 plus 60, that's 260. And if we want to solve for y, we just take 360 and subtract 260, and we get 100. So y also equals 100. Okay. Are these guaranteed to be parallelograms? Yes or no, why or why not? And you can look at number 11 for our proof that parallelograms are quadrilaterals are parallelograms. So in order to prove that these quadrilaterals are parallelograms, one of these 5 things needs to be shown here. So let's look at this. Fold this over. All right, and A. What do we have here? We have opposite sides are congruent. Oh, if both pairs of opposite sides are congruent, we know this is a parallelogram. So yes. If both pairs, and I'll let you write the rest, of opposite sides are congruent, then parallelogram. For B, we have one pair of opposite sides that's congruent and the other pair that's parallel. Okay, that's not enough information because one pair of opposite sides has to be both parallel and congruent, and this is just one pair is congruent and the other pair, it's not the same pair of opposite sides, the other pair is parallel. This is not enough information. Not enough info. Not enough info. It could be a trapezoid, an isosceles trapezoid. Okay, C. Here we have a pair of opposite sides that is both congruent and parallel. Oh, so that does work. So yes, and you can write the reason. If one pair of opposite sides is one, then it's a parallelogram. Okay, D. We have opposite angles that are congruent. Oh, that's enough right here. Both pairs of opposite angles are congruent, so yes. Both pairs of opposite angles are congruent. So then it's a parallelogram. And here we have consecutive angles that are supplementary on one side, but that's not enough information. We would need to have this angle and this angle be, these two opposite angles be congruent. We need some other things to be happening here. This is not enough info. It doesn't match our 5 criteria. Okay. Letter F, looking carefully at these pieces are congruent and these pieces are congruent, but that does not mean that this diagonal bisects this diagonal. These two pieces would have to be congruent in order for these two to be, so no. Letter G, we have, in this case, the diagonals are bisecting each other, this piece is congruent to this piece, it's been bisected, and this piece is congruent to this piece, it has been bisected. So this is yes. Diagonals bisect each other, then you have yes. If diagonals bisect each other, and write neater than me, I'm writing kind of sloppy. If diagonals bisect each other, then it's a parallelogram. Okay, let's look at this last one. We have opposite sides that are congruent. Then we have the measures of these angles. And remember, these are alternate interior angles. Now you have to be careful here. Where is our z? And it looks to me like the angle goes like this, right? Up, over, and up. And those are our alternate interior angles. So the z goes sideways, which means that this side is parallel to this side. Okay? So this is kind of like here in letter B. We don't have the same pair of opposite sides that's both congruent and parallel. We just have one pair that's congruent, then the other pair is parallel. So this is not enough info. So no, not enough info. Is a square sometimes, always, or never a parallelogram? A square is always a parallelogram. If you look at your flow chart, you know, we start with the parallelogram. I don't know the flow chart really, that's unfortunate. But you start with the parallelogram, and then a square is a type of parallelogram. A rhombus is a square. Remember, a square has 90-degree angles. But a rhombus can sometimes be a square. They both have congruent sides. All their sides are congruent. If the rhombus happened to have 90-degree angles, then it would be a square. So it sometimes happens. A square is always a rhombus, but a rhombus is only a square when its angles are 90 degrees. The diagonals of a trapezoid are congruent. That is sometimes. When are the diagonals of a trapezoid congruent? When it is isosceles. So if you have an isosceles trapezoid, then you will have congruent diagonals. Otherwise, you don't have them in just an ordinary shaped trapezoid. Okay, which quadrilaterals always have opposite angles that are congruent? Okay, so which ones always have opposite angles that are congruent? Okay, parallelograms have opposite angles that are congruent. A rectangle is a type of parallelogram, so it always has, in fact, they're all 90 degrees. A rhombus always has opposite angles that are congruent because it's a parallelogram, and same with square. So these are all types of parallelograms, remember. Special types. So they're all going to have opposite angles that are congruent, just like the parallelogram. Number 23. Which quadrilaterals always have diagonals that bisect opposite angles? Now this is the kind of diagonal that bisects the angles, not each other. And that only happens with the rhombus. Okay, so this is a rhombus. And it happens with the square, because the square is a type of rhombus. So the diagonals will also bisect the angles. But it does not happen with a rectangle or just regular parallelograms. Okay, and that's the study guide. I highly recommend you pause as you're going through it. Hopefully you try them and pause and rewatch, etc., etc. And I'll see you soon.